Oh, the slow pan.
Amar,
Yes,
tell me if a penny falling off of the Eiffel Tower would kill a person.
Okay, so something Laura asked me earlier, so I decided I was actually going to work out. I'm kind of shocked. Okay, so the first thing I did, I found out the Eiffel Tower is about 301 metres tall. This bit may not all stay in. 301 metres tall. So the penny's going to fall from 301 metres at 9.8 metres per second. That's how fast it'll accelerate.
A second per second.
Yeah. It'll get faster by 9.8 metres per second every second. So in 2 seconds it'll be going 19.6 miles an hour. And so on and so forth. Your face is great.
Why is it 9.8 per second?
That's how fast gravity accelerates things on planet Earth.
Okay, so anything falling would be 9.8. Even a feather?
Ignoring air resistance. That's nice. Yeah, so I worked this all out, and at this speed, a penny, this acceleration, a penny would hit the ground, travelling at 76 metres per second, which is about 170 miles an hour. Chalk. You're littered with chalk. 171 miles an hour? Oh, that's what you're doing.
It hits the floor at 171 miles per hour. How do you work that?
I used a thing called the splash calculator to work out for me. Because you need a graph and stuff really, but I didn't have one of those for equations.
I've never thought about how you measure the impact that something has.
That is in joules.
Oh, okay.
And that would hit at this speed with 10 and a bit joules, which is about the equivalent of me, 85 kilograms, hitting you at 1 mile per hour. So it's not actually that much.
Okay.
So this is all theoretical. In actual fact, it doesn't hit with this speed at all. What happens is because it's
Then why are you telling us this?
Because that's how quickly it will go. Because it's a myth type thing. It's an urban legend, isn't it?
Oh.
That's the equation.
I don't know, Amar.
That's what you might hear from people. In actual fact, it won't be able to go that fast at all. What will happen is it will reach terminal velocity, which is when an object free falling in the Earth's atmosphere, because there's air in the way, it can only get to a certain speed. It won't continue accelerating forever because there will be too much air resistance. And for a penny, I looked up quite a few sources. There was none exactly for a UK penny, but roughly it came out at about 22 metres per second, and that's a top estimate-ish. 22 metres per second, the terminal velocity for a penny in Earth's atmosphere. That's about 50 miles per hour. And at that speed, working out terminal velocity and all that kind of stuff, it would actually hit the ground with a staggering 0.8 joules of energy, which is the same as me hitting you, 85 kilograms again, at 0.3 miles per hour.
So less?
Like this fast.
Less than what you said. Oh, really?
Yeah.
So it's not going to kill someone?
Well, it won't kill you. But because it's small, like a bullet, I worked out how much a bullet would do as well. You can get a .22 bullet, which is about a little bit less heavy, a little bit lighter. There's a word there, less heavy. It's lighter.
You're clever.
A .22 bullet, that would hit with about, that goes at about 700 miles per hour. So it wouldn't, it's nothing, it's like not anything compared to a bullet or anything like that. Ow.
My ovary. I've lost my penny.
Bullets go a lot faster than weigh the same amount, which is why bullets do so much damage. They're also aerodynamically shaped.
And they've got gunpowder in them.
They don't have gunpowder in them, they have gunpowder that shoots them.
Yeah.
In conclusion, the penny wouldn't kill you, it would just sting a little bit, so just keep your penny and buy something with it.
Thanks,
Stop throwing your nose up the Eiffel Tower, you dick. Terminal velocity for it.
Did it kill you?
Why do you throw like that? In the Earth's atmosphere, it would go actually about 22 metres. Let's get the shit out of me.